Good morning, students. I hope you're doing well. Let's take a look at our activities for Friday, May 8th. When you click on the link for Friday, May 8th, you'll see a few items listed here. Your directions tell you you're going to apply our concepts of radioactive decay, half-lives, to find the age of some items. We're going to demonstrate that by doing a lab titled Half-Life of Pennies. There's a nice video to remind yourself about radioactivity and half-life that you should watch before you begin your lab. When you open up the lab, you'll notice it has a little introduction about one of the more common elements used for radioactive dating, carbon-14. It's then got a section about vocabulary terms, some of those key ideas from your reading last class that you need to make sure that you understand correctly. So go ahead and look back at your notes or the reading and make sure that you define those items to begin with. When it comes to your procedure, you have two different options. If you happen to have 100 pennies or 100 coins of the same kind in your house, you can flip actual coins for this activity, and then you would use procedure number 1. If you can't find or don't feel like counting out 100 pennies or quarters or nickels or whatever coin you might have, you can use procedure number 2. You'll need to click on this link, and it's going to take you to a random coin flipper. This will allow you to select the number of coins that you would like to flip. It will randomly flip them and report back as either heads or tails. The first thing you need to do is select your type of coin. Here on this big drop-down menu, you can choose pretty much any coin I think you want because they're all going to be one side or the other. I use the United States penny just because it's what procedure number 1 calls for. You're then going to flip all 100 coins. So you want to choose 100 from the smaller drop-down menu here where it says flip 100 virtual coins. Go ahead and flip those coins. This is going to give you a picture here of 100 pennies. Your job is to count up how many are heads and how many are tails. You can go through your rows and count them all up and see how many of each one you have. Your directions then tell you to make sure to count the number that are heads and record it in the total coins removed. So in this first shake or first flip, let's say that 52 of them were heads. That would mean that 48 were tails, and your tails value goes in your number of coins remaining. The coins removed, or heads, goes over here in this column. So we had 48 coins remaining, or 48 coins that were tails. Now we'll go back to our coin flipper, choose the go back, and this time we need to reset it for the number of tails we had left. In my example, it was 48. So I'll set it up for 48, and I'll flip the coins again. Once again, you're going to have to count up how many were heads, how many were tails. Let's say, for instance, out of those 48 that were flipped, another 24 of them were tails. So 24 would remain. 24 more were removed, but instead of 24 here, we want the total number of coins. So 58 plus 24 would make this value 76. Notice how the number of coins remaining and the total coins removed always add up to 100 because that's what we started with. And that would be like the total amount of a starting radioactive material. So now we've got 24 coins left. We'd go back to our random coin flipper and change it now to 24. And flip again. Count up all of the tails. Let's say there were 13 of those that were still tails. That would mean that 11 or 87 have been removed. You'd keep doing this over and over and over and over and over until your value reaches 0, until your number of coins remaining equals 0. Once you've collected your data, you're going to need to make a graph. This time around, your directions tell you to create a line graph for the half-life of pennies. Use the number of pennies remaining as your dependent variable, so that would be your y-axis, and the shake number as your independent variable, which would be your x-axis. Remember, a line graph has points that are connected by a line. After you've completed your graph, you need to answer your analysis questions in complete sentences. Make sure to support your answers with examples from the experiment. So, for instance, if you say, how many shakes did it take to get rid of all of the pennies? You would answer something like, in my 8th shake, I had 0 pennies remaining. Same type of thing with these other ones. You want to make sure that you're quoting information from your lab. If you say something like, according to my graph, this many pennies should be remaining after 3 shakes, things like that, you want to make sure that you're quoting your data. After you have answered your analysis questions in complete sentences, support your answers with examples, then I want you to go through and look at your rubric. This tells you exactly what I'm looking for in grading on your activity. Here, for instance, your definitions are worth 5 points. If you copy down definitions from your reading or from your notes into your lab, you get 5 points, or 25% of your grade just for identifying those words that you should have learned last class. Recording your data is worth another 5 points. Turning it into a graph is worth 5 points. And then there's 5 points for your analysis questions for a grand total of 20 points. I've noticed on several of these labs, students are not creating graphs. They're skipping over this giant bold section that tells you to make a graph. And automatically you're setting yourself up for the best score you could get is a 75%. So please make sure that you're completing all parts of your lab and double checking your work with your rubric. If you have any questions, please do not hesitate to send me an email and let me know how I can help. I hope you have a wonderful day, and we'll see each other next class.